section 14.4, the hyperbola. A hyperbola is a locus of all points whose difference of distances to two fixed points called foci are the same. So this is my hyperbola. So if you take any 2 points on the, say take a point on the hyperbola, and you look at the difference between these two distances, take another point on the hyperbola anywhere, say over here, and take the difference between the two distances, then these differences are the same. For any 2 points on the hyperbola. Okay, so so again you have 2 fixed points. So you have a focus here, another focus, and the hyperbola is the locus of all points whose difference of distances to these fixed points are always the same. So if I take the midpoint of these two foci, this will be called the center of your hyperbola. If I take a line passing through the foci, that's called the real axis or the focal axis. If I take a line perpendicular to the real axis, passing through the center, then that's called the imaginary axis. If I take points that intersect the real axis and the hyperbola, then these are called vertices. So here's one vertex, and here's another vertex. Next, and maybe I'll draw it again. We have something called a bounding rectangle. Okay, so this is called a bounding rectangle. And each of these lines would be called an asymptote. My center will be where these two asymptotes, the two diagonals of the bounding rectangle, intersect. The hyperbola, well, will look something like this. It will approach each of these asymptotes, but won't quite touch them. Well, you're not supposed to touch them or anything or pass through them as best you can. Okay, so these are your vertices. And each of these are an asymptote. So these are your asymptotes here. So you approach, but you don't touch or pass through the asymptotes. And of course you have some foci here. You also have some imaginary vertices. I'll put them along here, along the imaginary axis. Okay, so this is what an asymptote looks like. Let me just check this for 1 second. Okay, that seems to be okay. Okay, so, oh, and of course, this is your hyperbola. Oops. This is your hyperbola. Okay, so let's try to find the equation of hyperbola through, well, with center at the origin. And suppose that the real axis and the y-axis, well, maybe I say the real axis is equal to the y-axis. So let's try to find the equation of this. Okay, so suppose I have some bounding rectangle. And let's say this is the y-axis. This is the x-axis. Let my vertex here be at 0b, 0, negative b, and my focus be here at 0c, 0, negative c. Okay. And so my center here is at the origin. And suppose that this here is at A. Now, let's look at the hyperbola. Let's take a point with coordinates x, y. I know that this distance between this point on the hyperbola and one foci minus this other distance between the point and the focus, that those differences should be, of distances should be the same. Let's also just look here before I even start. Let's look at this point here. So this distance here to the focus is going to be C minus B. And then this distance to the other focus is going to be, well, this is B plus C. And so we have to have that these difference of distances are the same. Oh, I don't know. Say D2 is bigger, so D2 minus D1 must equal, maybe I'll put absolute value because I'm not sure which one is bigger. It's got to be the distance, the difference of these two distances. So B plus C minus C minus B. Well, so that's B plus C minus C plus B. That's 2B. So the difference in their distances is 2B. And we also see from here that A squared plus B squared equals C squared by Pythagorean's theorem. We have here A squared plus B squared equals C squared. So let's look at the difference of these two distances. I don't know which one's good. Well, I'll just say this in this picture. Okay, so it'll be D2, the square root of the difference of the x coordinates, x minus 0 squared. Difference in the y coordinates, y minus the negative c squared. D1 would be x minus 0 squared plus y minus c squared. Okay, good. And so I have that the square root of x squared plus y plus c squared minus the square root of x squared plus y minus c squared is equal to d2 minus d1, which is just 2b, But I'm not sure if this is positive or negative, so I'll put plus or minus because it's equal to its absolute value, whatever that is. So let's add radical x squared plus y minus c squared to both sides of my equation. So I get radical x squared y plus c squared equals radical x squared plus y minus c squared plus or minus 2b. Square both sides of your equation. The square gets rid of the square root. X squared plus y plus c squared equals, square that, so it's x squared plus y minus c squared and plus or minus 4b rad x squared plus y minus c squared plus 4b squared. Okay, good. So let me multiply this out. Well, first off, cancel out the x squares. And maybe I'll bring this guy over. Minus 4b squared. Okay. So if I do that, I get x squares cancel, so I get y plus c squared minus 4b squared equals y minus c squared plus or minus 4b rad x squared y minus c squared. Okay, so let me multiply this out. So by special product formula, y squared plus 2yc, or cy, plus 2cy plus c squared minus 4b squared is equal to y squared minus 2cy plus c squared 4b rad x squared y minus c squared. Okay, so let's simplify this. Subtract y squared, add 2cy, cancel out the c squares. So you get, cancel, 4cy minus 4b squared is equal to plus or minus 4b rad x squared y minus c squared. Divide by 4. So you get cy minus b squared equal plus or minus b rad x squared y minus c squared. So now let me just square both sides of my equation. So I get c squared y squared minus 2c or b squared cy plus b to the fourth is equal to, the plus or minus cancels because I'm squaring. So we got b squared x squared plus, let's multiply this out. So I get y squared minus 2cy plus c squared. Okay. So multiplying this inside the parentheses, the b squared inside the parentheses, I get by the distributive property c squared y squared minus 2 b squared cy plus b to the fourth is equal to b squared x squared plus b squared y squared minus 2 b squared cy plus b squared c squared. Okay. Let me subtract c squared y squared from both sides of my equation. Add 2b squared cy to both sides of my equation. Subtract b squared c squared from both sides of my equation. So I get b to the fourth minus b squared c squared equals b squared x squared plus b squared y squared minus c squared y squared. So let's group these and factor out. So I have a b squared, then a b squared minus c squared. I have a b squared x squared. I have a b squared minus c squared y squared. But from the beginning line, b squared minus c squared is just a squared. So if I look at this, I have that. Oh, I wrote, well, b squared minus c squared. I have that a squared equals c squared minus b squared. Okay, and so b squared minus c squared is negative a squared. So I have a negative a squared b squared equals b squared x squared minus a squared y squared. Let me divide both sides of my equation by negative a squared b squared. Okay, so I get a negative x squared over a squared plus, minus and minus make that a plus, y squared over b squared equals 1. And so that's the equation of my hyperbola centered at the origin. With my vertices. Oops, I didn't write b squared. With vertices at 0 plus or minus b, and the imaginary vertices at plus minus a, and with foci at 0 plus or minus c. With asymptotes, but I can say that with asymptotes, b minus b over ax. Okay. Since I look here at the slope, it's b rise over run b over a, and well, this one would be a negative b over a. Okay, well, if I just interchange x and y, basically just instead of having the vertices along the y-axis, if I have them along the x-axis, so we have this hyperbola. Something like this. So rather than, so then the foci will be here, vertices are here, center, and your asymptotes. And so, if I have, let's see, maybe I can put, this will be A, C, minus A, minus C. This is B, minus B. So, if I have here x squared over a squared minus y squared over b squared is 1. The center is at the origin. Vertices at plus or minus a 0. Foci at plus or minus c 0. And asymptotes are plus or minus b over ax. Okay, so that's another way of orienting the hyperbola. So instead of looking like this, if it looks like this, then notice that if it looks like this, means it goes through the x-axis. And so if all of the, if the focal axis, the real axis is the x-axis, then they'll be positive. If the focal axis, the real axis, is the y-axis, then that's the one that has the plus in front of it. So you can tell the difference. Notice that this has the plus in front of it, and so the real axis is in that direction along the x. Whereas if this had a plus in front of it, the real axis would be along the y. Okay. course, you can do a little bit of translation. You get the same thing. So if you have a hyperbola, and let's say it's centered at h, k, let's see, this is the bounding rectangle, and x is first, so it looks something like this. So this is h, k, then this distance here is a, this distance here b, and the distance here to the focus c. Then we have the vertice, the center is at hk. The vertices, they're also the other imaginary vertices, but I'll give you the real vertices. The real vertices are at h plus or minus a k. The foci are at h plus or minus c k. And remember, a squared plus b squared equals c squared. I should have said that for each of these. The asymptotes, y minus k is equal to plus or minus b over a x minus h. Okay, and then the other hyperbola, so you have some bounding rectangle. So it looks something like this. Okay, so h, k, a, b, c. Then we have x minus h squared over a squared, y minus k squared over b squared equals 1. Okay, the center is at hk, vertices h, k plus or minus b, a squared plus b squared equals c squared. The foci h, k plus or minus c, the asymptotes y minus k plus or minus b over a x minus h. Okay, so those were all the equations for the hyperbola. Okay, so where would you encounter hyperbolas? So where do you see hyperbolas? If you happen to have a comet that passes by the sun once, it could possibly be going in a hyperbolic curve. Okay. Actually, it's probably more likely if it only passes once to be in a hyperbolic path. Next, suppose you have so you're looking through some sort of telescope. Okay. Then you have a mirror here. And so this reflecting mirror is hyperbolic. You then usually have in here a parabolic mirror also. And then it goes to your lens, which is basically parabolic. Okay, so you have these series of mirrors that focus everything into your eye, basically. So usually it's done in most modern telescopes as a combination of hyperbolic and parabolic mirrors. Okay, so let's do some examples on page 615. Let's do problem number 1. X squared over 16 minus y squared over 9 is equal to 1. Okay. In exercises 1 through 6, graph the equation given in standard form and give the length of the real axis. Okay, so let's do this. So first off, the center of this hyperbola is the origin. A is square root of 16, 4. B, square root of 9 is 3. C, 16 plus 9 is 25. The square root of 25 is 5. The asymptote is given as y is equal to plus or minus b over a x. So let's do this. Okay, so a is 4. B is 3. Draw the bounding rectangle. Okay. So A here is your 4. B here is your 3. Draw your asymptotes. The diagonals for this bounding rectangle. So the first thing you draw is your bounding rectangle. And then you draw the diagonals of the bounding rectangle. This gives you the center. Now, the x has a plus in front of it. Therefore, these will give you your vertices. And try to draw. Well, the asymptote here is at 5. I'm sorry, the foci is at 5. Draw your hyperbola. Goes through the vertex, approaches, but doesn't touch each of these asymptotes. Okay, so that's your hyperbola. So here are your foci, your vertices, and your center. And here are your asymptotes. So here's your center. The vertices are at plus or minus 4, 0. The foci, plus or minus 5, 0. The asymptotes, oh, I already have the asymptotes. Notice rise 3 over run 4, and it goes to the origin. So that's the equation of foci. The length of the real axis, well, this length here, 4 plus 4 is 8. Okay. Okay, let me do problem 3. X squared over 4, y squared over 9, is equal to 1. So the center is at the origin. A is 2, B is 3, 4 plus 9 is 13, so C is the square root of 13. The vertices will be at, well, the x is the sign in front of the x squared is positive, and so the vertices will be at plus or minus 2, 0. The foci at plus or minus rad 13, 0. The asymptotes will be at y is equal to plus or minus 3/2 x. So let me draw this. Okay, so 2 3 1 2 3. So here are the diagonals of your bounding rectangle. And the x is positive. So this is my hyperbola. Here are the vertices, center, foci. And here are my asymptotes. 5. Y squared over 9 minus x squared over 25 goes 1. So the center is at the origin. A is 5. B is 3. 9 plus 25 is 34. So C is the square root of 34. The vertices are at the y is positive. 0 plus or minus 3. The foci are at 0 plus or minus rad 34. The asymptotes are y is equal to plus or minus 3/5 x. Let me draw first the bounding rectangle. So 1 2 3 4 5 4 5 1 2 3 1 2 3. Here's my bounding rectangle. Here's my diagonal of the bounding rectangle. The asymptotes. Okay. Y is positive, so, and square root of 34. This is 3. Ooh, it's about here. So here are my foci, my vertices, my center. Here are my asymptotes. And this, oh, is horribly bad. Let's try that again. See if I can do this. And here is my hyperbola. And that is what the graph looks like. Oh, I forgot the length of the real axis. And I forgot the length of the real axis here too. So length of the real axis, so that's going to be 4. The length of the real axis. Two times 3, 6. Let's do problem 7. X squared minus 4y squared equals 4. Okay, so first thing, let me divide both sides of my equation by 4. So I get x squared over 4 minus y squared over 1 equals 1. So in this case, the center, of course, is at the origin. A is 2, B is 1, C, 4 plus 1 is 5, so square root of 5. The vertices will be at x is positive, plus or minus 2, 0. The foci will be at plus or minus rad 5, 0. The asymptotes be y is equal to plus or minus 1/2 x. The length of the real axis is going to be 4. So 2 times 2 is 4. And so let's draw this. So it should be 2 in the x, 1 in the y. Okay. Let's draw the bounding rectangle along with its diagonal. And let's see, x is positive. Okay. So here, and square root of 5. Here are their foci, vertices, center, asymptotes. So it should look something like this. And there is your hyperbola. 9. 9 y squared 4x squared 36. Divide both sides of the equation by 36. So you get y squared over 4 minus x squared over 9 is equal to 1. So the center is at the origin. A is 3, B is 2, 4 plus 9 is 13, so C is the square root of 13. The vertices will be at y is positive, 0 plus or minus 2. The foci will be at 0 plus or minus rad 13. The asymptotes will be y is equal to plus or minus 2/3 x, and the length of the real axis is 2 times 2, 4. Okay. So let's draw this. Okay, so go 3 in x, 2 in y, draw the diagonal of the bounding rectangle. And so y is positive. So here are your centers, your vertices, and square root of 13. About here. Here are your foci. And this is what your hyperbola should look like. And here are your asymptotes. Okay. 11. 4x squared. No, I see it's the same as that. Okay. 4x squared. 9y squared equals 36. Divide both sides of your equation by 36. So you get x squared over 9, y squared over 4 is equal to 1. So the center is at the origin. A, 3, B, 2, C, 9 plus 4, 13. So radical 13. The vertices are at plus or minus 3, 0. Foci are at plus or minus rad 13, 0. Your asymptotes y is equal to plus or minus 2/3 x. Well, these all look very almost the same as above. And the length of the real axis, two times 3 is 6. So my graph looks something like the following. So you go 3 in the x, 2 in the y. So here's my bounding rectangle. Here are my asymptotes. And let's see. Here are my vertices, center, vertex, about here. Here's my foci. So foci, vertices, center, asymptotes. And so it should look something like this. And that is my hyperbola. So notice that these last two equations were virtually the same, or the same. The only difference is that the bounding rectangle is the same. It's just that the orientation of the hyperbola is different. Okay, 13. X plus 2 square over 25. Y minus 1 square over 16 equals 1. Okay, so the center is at -2, 1. A is 5. B is 4. C, 25 plus 16 is 41. So square root of 41. The vertices are at, maybe I should just do it this way. -2 plus or minus 5, 1. The foci are at -2 plus or minus rad 41, 1. The asymptote maybe I'll put it on the next page. So the asymptote y minus 1 equals plus or minus 4/5 x plus 2. And the length of the real axis Oh, 2 times 5 is 10. Okay, so let's do this. So which always going to be slightly bigger. So it's at -2, 1. It's my center. You go 5 in the x. 1, 2, 3, 4, 5 in the x. 1, 2, 3, 4, 5 in the x. You go 4 in the y. 3, 4. 1, 2, 3, 4. Let's draw my bounding rectangle. Draw the diagonals, which is going to be my asymptotes. Okay, and let's see. X is positive. Okay, so here's the center. Here are my vertices. And focus is rad 41, so it's over 6. So it's about here. For each of my foci. Okay, so, and here are my asymptotes. So here's my hyperbola. Okay. $14, $15. X minus 3 square over 9 minus y plus 2 square over 4 equals 1. So the center of my hyperbola is going to be 3, -2. A is 3. B is 2. C, 9 plus 4 is 13. So the square root of 13. The vertices will be at 3 plus or minus 3, negative 2. The foci will be at 3 plus or minus rad 13, negative 2. Your asymptote will be y plus 2 equaling plus or minus 2/3 x minus 3, and the length of the real axis. Two times 3 is 6. So the center is at 3, negative 2, 3 in the x, two in the y. So that gives me my bounding rectangle. Let's draw the diagonal. So the x is positive, and square root of 13 is about here. Okay, so here are your foci, your vertices in the center, and here are your asymptotes. And so the graph, the hyperbola, should look something like the following. (17) y plus 2 squared over 16, x minus 3 squared over 25 equals 1. So the center of this hyperbola is 3, negative 2. A is 4. B is 5. C, 16 plus 25 is 41. Square root of 41. So your vertices are at the y is positive. So 3 minus 2 plus or minus 5. Foci are at 3 minus 2 plus or minus rad 41. Your asymptote has the form y plus 2 equals plus or minus 5/4 x minus 3. That's the equation of your asymptotes. And then the length of the real axis. 2 times 5 is 10. So let me draw this. So the center is at 3, negative 2. I go 4 in the x. 1, 2, 3, 4. 1, 2, 3, 4. 5 in the y. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And so this is my bounding rectangle. Here are my diagonal. Ooh. And it's got to be y. Oops. So it's got to look something like this. Okay, so that's your hyperbola. And that's your answer, 19. X squared minus 9y squared minus 2x equals 8. In exercises 19 through 27, use completing the square method to convert the equation to standard form. Use extended diagonals of the fundamental rectangle to sketch the graph. Okay, so let's group x's together, y's together, and complete the square. So, negative 2 divided by 2 is negative 1. Squared is 1. Let's add 1 to both sides of my equation. Divide every term here by 9. So I have x minus 1 squared over 9 minus y squared over 1 equals what? Okay, good. So in this case, the center is at the origin. No, it's not. It's at 1, 0. So the center is at 1, 0. A is 3. B is 1. C, 9 plus 1 is 10, so the square root of 10. So my vertices are at the x is positive, so it's going to be 1 plus or minus 3, 0. The foci are at 1 plus or minus rad 10, 0. The asymptotes y is equal to plus or minus 1/3 x minus 1. So let me draw this. Let's not make it too big. I won't be able to fit everything on this whole page. And so 1, 0 is my center. Go out 3 in the x. One in the y. Draw my bounding rectangle. Now it's kind of small, but draw the diagonals. And let's see, x is positive, so square root of 10, pretty close. And so here are the hyperbolas. So here are your asymptotes, foci, vertices, and center. 21. Negative 4x squared negative 8x plus y squared minus 4y minus 4 equals 0. Group the x's together. Let's factor out a negative 4, x squared plus 2x. Group the y's together, y squared minus 4y. Bring the 4 to the other side of my equation, and let's complete the square. Two divided by 2 is 1. 1 squared is 1 times negative 4 is negative 4. Negative 4 divided by 2 is negative 2 squared is 4 times 1 is 4. The 4's cancel, so that's just equal to 4. Divide both sides of the equation by 4. So you get a negative x plus 1 squared over 1 plus y minus 2 squared over 4 is equal to 1. Okay, so the center is at negative 1, 2. A is equal to 1. B is equal to 2. 1 plus 4 is 5, so C is equal to the square root of 5. Therefore, the vertices are at, the y is positive, negative 1, 2 plus or minus 2. The foci are at negative 1, 2 plus or minus rad 5. The asymptotes have the equation, let's see, there it is, y minus 2 equals plus or minus 2 over 1 times x plus 1. And the length, and so let me draw this. Again, don't do it too big. Okay. So the center is at negative 1, 2. I go 1 in the x, 2 in the y. Draw my bounding rectangle. Draw my diagonals. And the y is positive. And so the square root of 5 about here. And this is my hyperbola. Here are your asymptotes, foci, vertices, and center. (23) x squared minus 25y squared plus 6x equals 16. Group x's together, y's together, complete the square. Six divided by 2 is 3, squared is 9, times 1 is 9. Let's add 9 to both sides of my equation. Divide every term here by 25, so x plus 3 squared over 25 minus y squared over 1 is equal to 1. So the center is at negative 3, 0. A is 5. B is 1. C, 25 plus 1 is 26. Square root of 26. So the vertices are at negative 3 plus or minus 5, 0. Foci are at negative 3 plus or minus the square root of 26, 0. And your asymptotes are y is equal to plus or minus 1/5 x plus 3. Let's draw this. Okay, so x is at negative 3. So 1, 2, 3 is the center. You go 5 in the x. 4, 5. 1, 2, 3, 4, 5. And you go 1 in the y. Okay, so my bounding rectangle is very flat. Looks something like this. My asymptotes. Looks something like that. And the thing that's positive is x. Okay, square root of 30, 26. 26, that's 5. 1, 2, 3, 4. Okay, oh, that's close. So foci, vertex, center, vertex, foci. So it should look something like and there, and these are your asymptotes. And that is what your hyperbola looks like. It's really flat. Okay, sounds kind of like squashed almost. 25. I didn't do 23, I did 25. Yeah, I just did problem 25. 21. Okay, I did 21, 25. Let's do 23. Okay, 23. 4y squared minus x squared plus 8y equals 0. Okay, so let me do that. So I have a negative x squared, grouping the x's together, plus 4. Let's factor out a 4. Y squared plus 2y equals 0. Let's complete the square. Two divided by 2 is 1. 1 squared is 1. Times 4 is 4. Divide both sides of the equation by 4. So the center in this case is 0, negative 1. A is 2. B is 1. C, 4 plus 1 is 5. So the square root of 5. The vertices are at 0, negative 1 plus or minus 1. Foci, 0, negative 1 plus or minus rad 5. The asymptotes are at 1, y plus 1 equaling plus or minus 1/2 x. Let me sketch a graph. Okay, so the center is at 0, negative 1. We go 2 in the x, 1 in the y. So here's my bounding rectangle. Let me draw the diagonals of the bounding rectangle. Let's give us our asymptotes. Y is positive, so square root of 5 here. And so here are my vertices, center, foci. And here's my, hyperbola. Okay, so, and here are your asymptotes. 23, so I did 25, let's do 27. 4 y squared 8y minus x squared plus 4x equals 4. Group the x's together. So I have a negative x squared minus 4x. Group the y's together. I have 4y squared plus 2y equals 4. Complete the square. Negative 4 divided by 2 is negative 2 squared is 4 times negative 1 is a negative 4. 2 divided by 2 is 1 squared, which is 1 times 4 is 4. So the 4's cancel. So you get equal to 4. Divide both sides of your equation by 4. And so I get negative x minus 2 squared over 4 plus y plus 1 squared over 1 is equal to 1. And so the center is at 2, negative 1. A is 2. B is 1. C, 4 plus 1 is 5. And so I have here there. The vertices are at 2, negative 1, plus or minus 1. The foci are at 2, negative 1, plus or minus we're at 5. And the asymptotes are y plus 1 equaling plus or minus 1/2 x minus 2. Sketch the graph. Center is at 2, negative 1. You go 2 in the x, 1 in the y, and here is your bounding rectangle. Draw the diagonals of the bounding rectangle, giving you the asymptotes. Y is positive, and square root of 5 is a little over 2. And so this is what your hyperbola should look like. Uh-oh. Okay. And here are your asymptotes. Foci, vertices, center. 29. Y squared over 9, x squared over 16 equals 1. So in this case, the center is at the origin. A is 4. B is 3. C 9 plus 16 is 25. Square root of 25 is 5. And so that says that the foci are going to be at, the y is positive, so 0 plus or minus 5. And those are your foci. 31. X squared over 36. Y squared over 64 is 1. So the center of your circle is at the origin. A is 6. B is 8. 36 plus 64 is 100. The square root of 100 is 10. So C is 10. The foci are located at, well, the x is positive, the sign in front of x squared is positive, and so it's going to be at plus or minus 10, 0. 33. Nine y squared minus 25x squared is equal to 225. Divide both sides of your equation by 225. And so I have negative x squared over 9 plus y squared over 25 is equal to 1. So in this case, the center is at the origin. A is equal to 3. B is equal to 5. 9 plus 25 is 34. So C is equal to 34. Therefore, the foci are located at, and y is positive, 0 plus or minus the square root of 34. And those are your foci. 35. The vertices are at plus or minus 3, 0. The foci, plus or minus 5, 0. In exercises 35 through 41, find the equation of the hyperbola satisfying the given conditions. Well, the midpoint of the foci will be the center. In this case, the midpoint is the origin, so the center is at the origin. Therefore, the equation of my hyperbola looks like x squared over a squared, y squared over b squared is 1. Now, since the foci are along the x-axis, that means that the sign in front of the x squared is positive, and the other sign, the one in front of the y squared, is negative. So let's figure out what this is. So they've given us A. A is 3. We don't know B, but I know that C is 5. Since a squared plus b squared equals c squared, then I have that 3 squared plus b squared is 5 squared. So 9 plus b squared is 25. Therefore, b squared is 16. So let's plug that in. So I have x squared over a squared, 9, minus y squared over b squared, 16, is equal to 1. And that is the equation of the hyperbola satisfying the given conditions. Now we do 37. The vertices are 0 plus or minus 4, the foci at 0 plus or minus 11. So this says that the center, the midpoint between the two foci, well, is the origin. Therefore, the equation of my hyperbola looks like, well, notice that the foci are along the y-axis, so the sign in front of the y squared must be positive, and well, the other one, the sign in front of the x squared must be negative. I'm given, I do not know a. I'm given that b is 4 and c is 11. I know that a squared plus b squared equals c squared. And so a squared plus 4 squared is 11 squared. So that says that a squared plus 16 is 121. And so a squared is 105, subtracting 16 from both sides of my equation. So I can now plug that into my equation. So I have a negative x squared over a squared, 105, plus y squared over 4 squared, 16, is equal to 1. That is the equation of my hyperbola. 39. The foci are plus or minus 8, 0. And the length of the real axis is 39, 6. I know that the center is the midpoint of the foci, which is the origin. And so the equation of my hyperbola looks something like x squared over a squared, y squared over b squared equals 1. Since the foci, the focal axis, the real axis, is the x-axis, then there's a plus in front of that x squared, and must be a minus in front of the y squared. So I'm given here that a, b, c. I know c is 8. The real axis, because this is plus, is along the x-axis. The real axis is length of real 6, so 2 times a is 6. Therefore, a must equal 3. I know that a squared plus b squared is equal to c squared. And so 3 squared plus b squared is 8 squared. So 9 plus b squared is 64. Therefore, b squared is 55. And so the equation of my hyperbola is x squared over a squared minus y squared over b squared is equal to 1. And that is the equation of my hyperbola. Let me do problem number 41. The foci are 0 plus or minus 9, and the length of the real axis is 12. Since the midpoint of the two foci is the origin, then the center is at the origin. I know the equation of my hyperbola must be, since the focal axis, the real axis, is along the y-axis, then the sign in front of the y squared must be positive, and the sign in front of the x squared must be negative. I don't know what A is. I know C is 3. We're given the length of the real axis. Well, the real axis is along the y-axis. Therefore, 2b is 12, and so b must equal 6. I know that a squared plus b squared equals c squared. And so a squared plus 6 squared I wrote something wrong. C is 9. It says 9 up here, not 3. Okay. That was a typo. Okay, so the C is 9. Okay. Okay, so everything else is correct. Okay, so I have that a squared plus 36 is 81. Therefore, a squared is 81 minus 36, 45. And so I have a negative x squared over a squared plus y squared over b squared is equal to 1. And so this is the equation of my hyperbola. 43. Nine x squared minus 16 y minus 1 squared is 144. In exercises 42 through 47, find the center, vertices, foci, and asymptotes of the hyperbola. Sketch the graph. So divide both sides of my equation by 144. X squared over 16 minus y minus 1 quantity squared over 9 is equal to 1. So the center is at 0, 1. A is equal to 4. B is equal to 3. C is equal to 16 plus 9 is 25. The square root of 25 is 5. And so the vertices are at x is positive. And so they're at plus or minus 4, 1. The foci are at plus or minus 5, 1. The asymptotes, y minus 1 plus or minus 3/4 x. So center, vertices, foci, asymptote. Okay. Well, this is really going to be tight. Let me try to sketch the graph of this. It's going to be a really tiny graph. Okay, so 1. You go 4. So that's the center is at 0, 1. Okay. You go 4 in the x. 1, 2. You go 3 in the y. 2. Okay. Here are your diagonals of your the diagonals of your bounding rectangle. And let's see. Oh, good. It's x's. Okay, so here is your center, your vertices, your foci at 5. And this is your hyperbola. There, it doesn't look as bad. Okay. Nah, that's not horrible. Okay, so that's your hyperbola. 45. Nine y squared minus 16x squared. 9y squared minus 16x squared minus 36y plus 32x minus 124 is 0. So let's do negative 16x squared plus 32x plus 9y squared minus 36y equals 124. Just grouping all the x's and y's together and bringing the constant term over to the right-hand side of the equation by adding 124 to both sides of your equation. Let me factor out the negative 16, factor out the 9, so I can complete the square. So negative 16, 9 for the y's. Okay, so negative 2 divided by 2 is negative 1 squared is 1 times negative 16 is negative 16. Negative 4 divided by 2 is negative 2 squared is 4 times 9 is 36. Divide both sides of your equation by 144. X minus 1 squared over 9, y minus 2 squared over 16 equal to 1. Okay, so that's the equation written in standard form. So the center for my hyperbola is at 1, 2. A is equal to 3. B is equal to 4. C, 9 plus 16 is 25. The square root of 25 is 5. My vertices. Y in front of the y squared is positive. And so my vertices are at 1, 2 plus or minus 4 foci, 1, 2 plus or minus 5 asymptotes. Y minus 2 equals plus or minus 4/3 x minus 1. And let me sketch the graph. I can bring this down then. Hmm. Let's see if I can squeeze it here. This might be a tight spot, but I guess I'll try. Okay, so go 3 and 4. Well, maybe. Okay, center is at 1, 2. Go 3. Okay. Center is at 1, 2. Go 3 in the x. 4 in the y. 1, 2, 3, 4. Okay, so here's my bounding rectangle. Draw the diagonals, your asymptotes for your hyperbola. Y is positive, okay. So here, and 5, so just one more. So here are your center, vertices, foci. And this is your hyperbola. And these are your asymptotes. $47. $16 x squared minus 9y squared minus 32x plus 36y minus 164 equals 0. Group the x's. 16x squared minus 32x. Y's together, minus 9y squared plus 36y. Bring the 164 over to the other side of the equation by adding 164 to both sides of your equation. Group, factor out the 16 from the x's. Negative 9 from the y's. So I can complete the square. Negative 2 divided by 2 is negative 1. squared is 1 times 16 is 16. Negative 4 divided by 2 is a negative 2. Squared is 4. Times negative 9 is negative 36. So you get 144. Divide both sides of your equation by 144. So you have x minus 1 squared over 9, y minus 2 squared over 16 equals 1. So the center is 1, 2. A is 3. B is 4. 9 plus 16 is 25. The square root of 25 is 5, so C is 5. The vertices are at 1 plus or minus 3, 2. The foci are at 1 plus or minus 5, 2. The asymptotes are y minus 2 equals plus or minus 4/3 x minus 1. Let's sketch the graph. So the center is at 1, 2. I go 3 in x. Yeah. 4 in y. Draw your bounding rectangle. These are your asymptotes, your diagonals of your bounding rectangle, or your asymptotes. And let's see the x's. Okay, so 5. That's 4, 5. So foci, vertices, center, asymptotes. So it should look something like and that's your hyperbola. Okay, 49. Actually, before I do 49, let me do this. So the curves of quadratic equations in 2 variables. So I want to see what the sketch of the graph of a quadratic equation, 2 variables, will look like. So suppose I have ax squared plus bxy plus cy squared plus dx plus ey plus f equaling 0. Okay, so let's assume that we have non-degenerate solutions. So a degenerate solution would be either an empty set, well, so a non-degenerate would be, so I'm assuming that it's not an empty set. The solution's not just nothing, nor is it a point. You know, you could have x squared plus 1 equals 0, so that have no real solution. You could have x equals 3, so that's just a point. Or x equals, you know, x equals 3, y equals 2. That would be a just a point in the plane. Nor do you want a line in the plane. You know, y equals 3x plus 7 or something. Nor two lines. So I don't, so you could have the absolute value of y equaling 2x or something. So you could have either two lines, one line, 1 point, no points at all. That would be called the degenerate solution. We don't want those. We want something. Okay. Now, define the discriminant as b squared minus 4ac. Then, if the discriminant is equal to 0, this will be a parabola. If the discriminant is greater than 0, this is a hyperbola. If the discriminant is less than 0, this is an ellipse. Okay. Well, that's for a general sort of quadratic surface. Let me look at a simpler case. So let me also look at the case of, you know, quadratic equations in two variables. With no xy term. So I can say a little bit more about this if I assume that this term here is 0. So let's say that we have something of the form ax squared plus by squared plus cx dy plus e equals 0. Okay. So now, if either a or b is 0, then this will be a parabola. Again, we're assuming non-degenerate. So I don't want any degenerate surfaces here. Okay, so if either A or B is 0, then this will be a parabola. Okay. Next, if the sine of A and B is negative, maybe I'll say it that way, so that A and B have differing signs, then this will be a hyperbola. Next, if A and B have the same sign, then this will be an ellipse. If, in addition to having the same sign, if they're actually the same numbers, then this will be a circle. So a circle is just a special type of ellipse. And we can sort of think of a hyperbola as being sort of like an ellipse that's gone off to the complex plane. And so it's sort of an ellipse that's been like blown up or something by going into the, or turned inside outwards by going into the complex plane. Okay, so let me do, let's see what problem were we were at 47. So let me do problem number 49 on page 616. Y equal negative 2 over x. In exercises 48 through 50, sketch the graph. Well, we've done this way back when. So this just looks like the graph of y equal 1 over x, which looked like this, reflected about the x-axis. And then we stretched it by a factor of 2. And so this is the graph to look something like this. Maybe, let me just draw it by itself. So it looks something like this. Let me draw this. Let's see if I can draw it better. So it looks something like, okay, now you may wonder, why in the world are we doing this from like several chapters ago? Okay, so what you'll notice is the following. If I multiplied this guy by x, I would get xy equals negative 2, which says, well, it's an equation of this form. where in this case, b is 1. So let's look at the discriminant. So the discriminant in this case is 1 squared minus 4 times 0 times 0, which is 1, greater than 0, which says, oh, it's a hyperbola. This is actually the sketch of a hyperbola. So what we've been drawing here is a hyperbola. So if you look at this, I don't know if I can draw this. It's sort of, here's my there it is. Okay, so here's my bounding rectangle, and here are my asymptotes for that bounding rectangle. Here's my real axis. Here's my imaginary axis. Here's my bounding rectangle. And here are my asymptotes. Which is what we called them back when we did this way back when. We called these asymptotes, the x and y axis. And we also said that you never cross these, you only went through and just barely and just got closer and closer to these asymptotes, but never crossed them or touched them. The reason for that is because this is a hyperbola. And so this is so in general, you can always go through asymptotes and touch them as many times as you want, cross them and do all the sort of things as you want. But in hyperbolas, we have the very special property that you approach but never touch nor cross your asymptotes. And so this fact that you never touched or crossed your asymptotes was the fact that it was a hyperbola. So we're using this very special fact that we didn't tell you, but what you'd been drawing all along was a hyperbola. So this is a hyperbola. Okay, let me do problem 51. 4x squared plus 4y squared equals 36. Okay, so I look here in exercises 51 through 58. Identify whether the graph is a circle, an ellipse, a parabola, or hyperbola. Okay. And so, in this case, both 4 and 4, with a sign in front of x squared, they're both of the same sign. They're both positive, and they're both equal. So since since A and B have the same sign, and since they're actually equal, then this says that this is a circle. So the sketch of this is a circle. Let me do problem 53. Four x squared 9y squared equals 36. In this case, the sign of both a and b are positive. So that says that this is an ellipse. 55. Negative 3x squared plus 2y squared is 18. Well, the sign of a and b are different. Therefore, one is the sign in front of x squared is negative. The sign of y squared is positive. So this is a hyperbola. To 57. Three x squared plus 4x minus 6y equals 8. So in this case, A is, the number in front of y, the y squared term, is 0. Therefore, I have that b is 0. Therefore, this is a parabola. So that finishes off section 14.4. 14.4, and we'll do 14.5 on Monday.